So you should have number, tally, frequency, relative frequency, and what are the number values that you have here. Looks like the smallest one is 6, 7, 8s, 9s, 10s, and 11s. So the numbers would be 6, 7, 8, 9, 10, 11, and doing a tally. First number is an 8, 7, 6, 7, etc. So how many 7s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 7s, 6s, 1, 2, 3, 4, 5, 6, 6 6s. Many 8s, 1, 2, 3, 4, 5, 6, 7, 8 8s. 9s, 1, 2, 3, 4, 10s, 2, 11s, 1. And be sure and add your frequency to make sure you haven't made a mistake, because there were 30 numbers, 15 and 8's 23, 27, 28, 29, 30, so everything looks fine. And then how do you get the relative frequency? You say, well, how many ended up in this category? 6 of the scores were in this category, so this is going to be 6 out of 30, and turn that into a decimal, and etc. for all of these. So this is how it should look. There's your tally, your frequency, and your relative frequency. If you put it on a column graph, it's called attendance on holiday program. You should always have a label for your horizontal and vertical axis. Again, your vertical axis is always going to be the frequency. Just get used to that. And what's the biggest frequency we had here? 9. So we only need to make this go like to 10. Previously, we had, in our previous graph, we had numbers all the way up to 50. So we did have to make a frequency table that went up to 50. And this time we did not. We just have numbers that went up to 9. So our frequency only needs to go up to 10. And then these will be our values here. Year level, 6, 7. The bars should be equal in width, and there should be a gap to show that it's discrete data, whole number data only. What's the mode? The mode is the item that happens the most often. You can either get it from here or from here. Here, visually, you can see the one that happened the most often is the 7. So you would say the mode is 7, or the 7th year. This is like grade 7. If you answered these questions, we're just the modal year level of the children. The mode was year 7, 7th graders. Describe the shape of this distribution. Are there any outliers? Well, what would you say about the skewing here? Is it kind of pushed over to the left? That's a positive skewing. So it's quite positively skewed. You might say it's either moderately skewed to the positive side, or quite skewed, but it's definitely skewed. Were there any outliers? There was nobody that was outrageously different from all the others. They were all 6, 7, 8, 9, 10, 11. Nobody was out here at like 13 or 18, or 13 might even be reasonable because it's close to these others. An outlier should be quite significantly outside the norm. Like if there was 115 out here somewhere, we might call that an outlier. These are very frequent IB questions. What percentage of the children were in year 8 or below? The percentage of children that were in year 8 or below. You can look either place. If we look here, year 8 or below, that implies that year 8 is in there, year 8 or below. So you'd add all of those up and turn that into a percentage out of 30. The tricky one here, what percentage of the children were above year 9? Above year 9. Are these people in grade 9 considered to be above grade 9? No, they're not. They're in grade 9. So above grade 9 would be these 3 out of 30, turned into a percent. So that first answer was 77% were in year 8 or below, and these 3 out of 30 is 10% here. So that's the end of 6A and 6B. We still have 6C, which is grouped quantitative discrete data. A statistics class wrote down the number of vehicles passing through the front gate during this 15-minute interval in the morning for 30 consecutive school days, and the data was tabulated here. So what does that mean? On day 1, 27 cars went through the gate in that 15-minute time period. On day 2, 30 cars went through the gates during that time period. Okay. On day 3, day 4, day 5, day 6, day 7, if you tried to make a bar chart out of this data, the bar chart would be quite broad because the numbers are from 13 to 50 something, and each one would be very, very small. How many 13s are there? There's only one 13, and one 9. There's 24, there's a couple of 24s, there's 3 24s. So you'd have one bar that's like 3 high, but most of these, there would be like 20 bars, and most of them would either be 1 high, or 2 high, or 1 high, and 1 and 2, and 1 and 1, and there are lots of numbers that aren't represented here. So there would be a lot of numbers that would have no bar at all. Like there might not even be a 27. I don't see a 27. I don't see a 33. So making a bar chart out of this data would be very useless. And so what you do with this is put it in what's called a group frequency table. And what you have to do is find the smallest value, which might be about 9, and the biggest value, which is 50-something, and decide how to put those in little groups to get 6 or 7 groups. You don't want your bar chart to have 30 bars, and you don't want your bar chart to have just 3 bars. Most bar charts that you look at, you may not have thought about it, but the bar charts are usually 5, 6, 7, 8, 10, 12 bars at the most, usually 6 or 7 or so bars. So how do you split this up into reasonable size? One way to do it, we'll talk about the actual formula for doing it later, but for right now, let's just use 0 to 9, 10 to 19. There was a number in this range, 0 to 9. There were several in here, and there was a 52, so we need 50 to 59 there for that category. That'll give us 1, 2, 3, 4, 5, 6 bars. So if we put them in these little groups, we'll get 6 bars. And what we'd do is we'd go back and start making a tally table. And 27, where does 27 go? Here. Put a tick. Okay, and go back. 30, where does 30 go? Put a tick. So what you should do right now is pause your quick time or whatever you're using. Pause right now and put these numbers into a frequency table in the categories where they belong. Okay, now that you've done that, I hope you paused and did that. We look at the tally table and the frequency, and there was only one 9, so there it is. How many were in here? 5. There you go. There's our 30 numbers. They don't ask for a mode anymore if it's grouped. They ask for a modal class, which means which group actually was. This is short for mode. And remember what we said the mode was? The most frequently occurring item? It's okay. The modal class is the class that happens most often. And if you look at this, which one did happen most often? The 20 to 29 class happened the most often. So the modal class, you would say 20 to 29 cars. To make a column graph for the data, remember that you want to leave a little space to show that it's discrete. Why was it discrete? Because how many cars were going through there? You wouldn't say that there were 4.5 cars or 4.6 cars or anything like that. You'd say during that 15-minute time period, 5 cars went through. So it's discrete, whole numbers. Whole numbers need a little space. And if you look at the way that they've written the numbers here, this is the group 0 to 9. They've got 10 starting right there to show that this group is 10 to 19, stopping there, leaving a gap before 20. So you can actually tell that it's discrete because it has a gap, but it does start at 0 and goes up to 9, so they've stopped this just short of 10 and started the next bar at 10 up to 19. So that's how a bar chart should look with grouped data. The thing that you lose about group data is you have no idea what the individual scores were anymore. You know that there were 10 scores, 10 cars in this group right here. Actually, this is 10 days. So on 10 days, there were between 20 and 29 cars that went through the front gate during that 15-minute period. But you lose the ability to know what the individual scores were. I keep calling them scores. but these are number of cars that went through on that particular day. That is the 5th day. So 46 cars went through on that particular day in this 15-minute time span. So you lose all of the individual data though, because you have here you know exactly what the scores are, but they're a mess. But once you put them in a group frequency chart or table, you lose all the individual scores, but you get a much more interesting, worthwhile visual picture of how it all works. Do you know what the greatest number of cars going through there was? No. 52 is lost in there somewhere. But, you know, that's okay.